Good day. We have talked in the previous video about LU factorization and how to get the value for both L and U matrices. We want to link this subject with the Gauss elimination process or the row echelon form. We use Gauss elimination through elementary row operations to convert the matrix A to an upper matrix, and later we use the back substitution to solve for the values of unknowns. For the given matrix A, which is 2 by 2, it is 2, 3, 3, 4. To convert this matrix into an upper matrix, we want the diagonals to be non-zeros and to let A 2, 1 to become 0. Using A sub 1, 1 as a pivot, divide A sub 2, 1 over A sub 1, 1, multiply by the minus sign by R1, and add the result to the second row R2. The new second row R2 will have a different value than the previous second row in the matrix A. We will have a new second row as 0 minus 1 over 2. As we have noticed that the first row of matrix A, there is no operation, and it is the same in the upper matrix, while the element U sub 2, 2, or the second row, second column, is equal to A sub 2, 2 minus A 1, 2 over A sub 1, 1. What about the lower matrix? We have, by definition, L sub 1, 1 equal to L sub 2, 2 equal to 1, and L sub 1, 2 equal to 0, because this is a lower matrix, while for the element L sub 2, 1, it is equal to A sub 2, 1 over A 1, 1, considering that A 1, 1 is a pivot. If we want to check whether the multiplication of L by U will lead us to the matrix A, which is 2, 3, 3, 4, we can use row column multiplication. 1 by 2 plus 0 by 0 equal to 2, and 1 by 3 plus 0 multiplied by minus 1 over 2 will give us 3, and then 3 by 2 multiplied by 2 plus 1 by 0, the final value is 3, and 3 over 2 multiplied by 3, and we add 1 multiplied by minus 1 over 2 will give us 4.5 minus 5 equal to 4. We have a valid LU through a valid multiplication. We will use the same matrix A to solve for the values of two unknowns X and Y. We have these two sets of equation, 2x plus 3y equal to 16 and plus 3x plus 4y equal to 18. It is required to find the unknowns values for x and y by using LU factorization method. The matrix A, which is 2, 3, 3, 4, is the same matrix for which the two matrices L and U were estimated earlier. Now we would like to use the expression of A equal to L by U to solve these two equations. We write A multiplied by X equal to B, and since A is equal to L by U, so we can write L multiplied by U multiplied by X equal to B, where B the vector column, which is equal to 13 and 18. We will use u multiplied by x and we call it C. So at the end we have the lower matrix L multiplied by C equal to B. We need to estimate the value of C because we know already the value of L and value of B, and then we can come back and return to get the value of the unknowns x and y. Since LC equal to B, we will multiply by the inverse of the matrix L. So L minus 1 multiplied by L by C will give us L minus 1 multiplied by B. So C will be the inverse matrix of L multiplied by B. In the lower matrix L, the elements are 1, 0, plus 3 over 2, and 1. Then its inverse L minus 1 we can estimate after getting the determinant value of L, which is 1 minus 0 equal to 1. We divide the adjoint matrix by the determinant value. We will swap and make change of sign. So 3 over 2 will be changed to minus 3 over 2, and the 0 will be the same. Multiply L minus 1 by B to get the C value. We have 1, 0, minus 3 over 2, and 1 to be multiplied by B, which is 13, 18. We will get the C value as 13 and minus 1.5. We proceed to get the value of x. Since u multiplied by x equal to c, we know c and u, we can get x value. The upper matrix is 2, 3, 0, minus 1 over 2, multiplied by xy equal to c. C, which we have obtained from the previous step at 13 minus 1.5. Again, we use the inverse of this matrix 2, 3, 0, minus 1 over 2. We make a swap in position between minus 1 over 2 and 2 and change the sign of plus 3 to be minus 3 to get the inverse matrix of u. The determinant value will be equal to minus 1. The inverse is 1 over 2, 3, 0, minus 2. We could double check this value by multiplying by u to get the identity matrix I. We multiply u minus 1 by c. The multiplication would be plus 1 over 2 multiplied by 13 minus 3 multiplied by 1.5 equal to 6.5 minus 4.5 equal 2, and we have 0 multiplied by 13 plus minus 2 multiplied by minus 1.5 equal to plus 3. We have x equal to 2 and y equal to 3. Last step, we would like to check if our solution is correct. So we'll substitute in the two equations, which are 2x plus 3y equal to 13 and plus 3x plus 4y equal to 18. We introduce x value as equal to 2 and y value which is equal to 3. Then, from the first equation, we have 2 by 2 plus 3 multiplied by 3 equal to 13, which will give us the right hand side as 13. While 3 by 2 plus 4 by 3 equal to 6 plus 12 equal to 12, which is already equal to the right hand side of the second equation. Both substitutions are okay. At the end of our solution, x is equal to 2 and y equal to 3 is the correct solution. In brief, to solve for x and y, get the inverse of the lower matrix and the inverse of the upper matrix. Set x equal to u minus 1 by L minus 1. Thanks a lot, and we will continue next time with another example. Goodbye.